Alright, so this problem actually deals with capacitors, capacitance, and calculating the equivalent capacitance, like the total capacitance, just like you would do in resistors. With capacitors, it's the opposite basically. So capacitors in series, instead of adding them like resistors, you actually inverse add, if that makes sense. But capacitors in parallel, you add them like you would add resistors in series. And we're going to do them and you will see it. But that's just a way to remember it. Capacitors are the opposite of resistors when it comes to calculating the equivalent capacitance. Alright, so here the question is finding, let me use a yellow pen. Alright, so basically here we're going to be inverse adding 24 and 12 and 8, and then add that to 4, because this total right here, 24, 12, and 8, they're in series, but the total is actually in parallel with 4. Alright, so this is what we have. We're going to redraw it. During the exam, you can do it using your calculator like really quickly, but here I'm going to actually redraw it so that you can see what we're talking about. Alright, so that'll be the 50. This is still the 4 microfarads. And this is, oh, I drew really bad. That's the 6 microfarads. Alright, so let's calculate the total equivalent for the parallel. So this still remains 5. That remains 5. So this is still your 4 microfarad, of course, and then this is still 6, and this is still between A and B, alpha and bravo, A and B. Alright, so this total right here would be 1 over 24 plus 1 over 12 plus 1 over 8. This would be 1 over, let's call it C1 maybe. Let's call it C1. So just using your calculator, C1 would be, I'm actually doing this live. You can also peer check me as well. So 1 over 24. I should have done this before I record this, but that's okay. 1 over 12 plus 1 over 8, and then inverse that. So that's 4. So C1 is equal to 4 microfarad. So this is a 4 over here. All right. So 4 and 4 are in parallel. So this one is easy. Parallel capacitors, you got to add them. Opposites of resistors. So then this becomes 8. Right? I don't have to redraw it. I can use a different color. Let me see what color. Let's use green. Alright, so this will be 8. Ooh. So this is in parallel, so this becomes 8 microfarad. So now 5, 8, and 6 are going to be in series. So just like what we did here, the total now will be 1 over 5 plus 1 over 8 plus 1 over 6. This will be the total now equivalent capacitance. So now the final answer would be just bear with me please, plus 1. I should have done this before, but I got 2. Doesn't make sense, but maybe it's correct. I'm gonna. All right, so I got 2 microfarads. I don't believe this for some reason. I don't. 1/8, 1/6. Hold on. Always check your answer. 1/8. Mm, 2. Maybe it is 2. For some reason, I was expecting when I plugged this into. I thought I had 20, but okay. So, but essentially, one thing to remember though is this right here, 1/, because a lot of students, the mistakes that actually we make is that we think that this is you're just gonna inverse add them, and that's your C. It's not. You gotta after you add them, you gotta inverse them again. So you make sure when you're adding 3 capacitors, when you inverse adding 3 capacitors, that's also the inverse of the actual capacitance. So like what I'm saying is this, for instance, 1/, whatever, plus 1/12 plus 1/8. A lot of students will just think that this is a whatever value it is, and then they start, plug it in here. You're gonna get that incorrect. That's not the case. This is 1/. This is the correct way to do it. All right, so I'm gonna check my answer again, but I think this is 2 microfarads. But you can peer check me as well and make sure that I get the correct answer, because we're doing this together, right? All right.